So the first lesson this week, I believe there's actually 4, but the first ones are real short, not too complicated. The last ones are a little bit tricky, so we're going to just take our time and work our way there. This first one is about adding, subtracting, multiplying, dividing radicals. This whole lesson is on radicals, and a lot of times people don't remember what that means. Anything under this little symbol, this is a radical sign. We see that and think square root. But the truth is you can have a cubed root, you can have a fourth root, and so on. But the symbol itself is called a radical symbol. Everything we're going to deal with today will be under a square root sign, but we're going to be dealing with radicals. The first thing we're going to look at is adding and subtracting radicals, and it's the same rules as like terms. You can only add or subtract like terms. Remember, if we had x plus y, we can't add those because they're not like terms. If we had x plus x, it became 2x. Radicals are the same way. The number underneath the radical has to match, or you cannot add them or subtract them. So let's just kind of jump into a couple of examples and walk through how to do these. Here's 3 examples. Let's work through them one at a time. So on example number 1, I just number this. I have to look at my radicals. And if the number underneath that radical matches, then I can add them. This is telling me I have 5 square root of 2's plus 3 square root of 2's, which means altogether I have 8 square root of 2's. The term, what I'm dealing with, doesn't change, only the amount of them changes. Let's look at example number 2. Oh, that's a terrible 2, but you know what it is. So this is telling me I have 6 square root of 5's, and I'm going to take 1 away. Don't forget, when you're dealing with something and you only have the term, you have an understood one. So technically, this is 6 square root of 5 minus 1 square root of 5, which gives me 5 square root of 5. Remember, what I'm working with, the square root of 5, doesn't change, just how many I have. I start with 6, and then I take 1 away. Now, when we get to number 3, things are a little bit different because square root of 5 and square root of 7 do not match, which means I cannot add them. That's as simple as this can get. And here is what happens a lot of times. We start adding through here, and we know that we can only add like terms in our brains, but then we see something like this, and we just want to be like, okay, 11 plus 4 is 15. 5 plus 7 is 12. Oh, so it's, nope, it's not. Okay, you can only add what matches. So when you can't add them, that just stays as your answer. Here are some practice problems I want you to look at. Now, don't panic at number 2. Just sort of think for a few minutes when you get to number 2. We're going to come back and work through these. So, oh, I yawned. So sorry. So take a second, work through these on your own, and then push play again, and we will work through them. All right. Hopefully you've worked through these, and let's do them together now. So you have 4 square root of 3 plus 5 square root of 3. Our radicals match, so I just add them. 4 plus 5 is 9, so I have 9 square root of 3. Now number 2 looks really odd because that x is under that radical sign. And so when letters or variables are thrown in, we sort of don't know what happens, but we just sort of get confused. But the thing is, the rules don't change. The rule is I can only add these if they match. Square root of x and square root of x match. So I have 11 square root of x's. I'm going to add 8 square root of x's to that. So I have 19 square root of x. Remember that what we're adding, the radical there, doesn't change. Okay, number 3, square root of 5 minus 6. Don't forget your understood one. And don't forget your negative and positive rules. So 1 square root of 5 minus 6 square root of 5 gives me negative 5 square root of 5. Remember, when we are dealing with opposite signs, we subtract and keep the sign from the bigger number. And then number 14, not 14, that's number 4. Square root of 15 and square root of 10 are not like terms. They don't match. And so this is my answer. I cannot simplify that in any way, shape, or form. Okay? So remember, when you're adding or subtracting, you have to have like terms. The term doesn't change, just the coefficient in front of it. One thing you need to kind of pay attention to, and this is another one of those things we know, we just sort of forget. Whatever sign is in front of that number becomes the operation. Okay? So you can only add like terms. Now when we're multiplying or dividing, we multiply and divide whole numbers, and then we multiply and divide radicals. So you do what it says, but you match up the whole numbers and then you match up the radicals. Let's do a couple. All right, square root of 7 times the square root of 6. There's no whole numbers or coefficients or big numbers in front, so we simply multiply what's under the radical. 7 times 6 is 42, so this is just the square root of 42. Now, there is no whole number solution to the square root of 42, so for right now, I'm going to leave it like that. If there was a square root, like if that was the square root of 49, then I would simplify it all the way down, but there's not a simple square root of 42. It's a big long decimal, so just leave it like that. Okay, so on this one, I have 2 square root of 3 times 4 square root of 5. You multiply whole numbers together. You multiply radicals together. So 2 times 4 is 8. Multiply your whole numbers. Multiply your radicals. 3 times 5 is 15. And that's it on that one. So you match up your whole numbers, and then you match up your radicals. Okay, let's look at the last one, because don't freak out. While this is a division line, you need to remember division means, that's a fraction line. It is a fraction line, but operationally, a fraction line means division. So really what this is 21 square root of 21 divided by square root of 3. When you're multiplying and dividing, they don't have to match. You just do the operation. 21 divided by 3 is 7. So this answer is the square root of 7. So operationally, when you're multiplying or dividing with radicals, you are still going to multiply and divide. They do not have to match. Just match up your whole numbers and your radicals. Let's do a couple of practice ones. Here is 4 practice problems I want you to try. Same thing, I would like for you to pause this, work this, see if you get them right, and then unpause it, and we'll check them. Okay. Let's look at number 1. I'm multiplying. How I know I'm multiplying is there are 2 things side by side, and 2 things side by side with no sign means multiply. So we're going to match up our whole numbers, and we're going to match up our radicals. 5 times 2, 10. 6 times 10 is 60. And for right now, we're going to just leave that as our answer. Later, we're going to, like in 2 lessons, know how to simplify that 60 down. But for right now, we're going to leave it right there. All right, this second one. 9 times 4 is 36. 2 times 2 is 4. Now, in this case, we have to go one step further. There is not a whole number square root to 60. If I take my calculator that's sitting right here, and I do, if I can find my square root button, square root of 60, I get 7.745 forever. However, there is a square root of 4. Square root of 4 equals 2. Now, what's happening between these two things? No sign means multiply. So technically what this is 36 times 2. When your radical simplifies down to a whole number, you need to go ahead and solve that down. Again, up here, there's no whole number square root of 60, so it just stays. When your radical has a solution, go ahead and solve it down. This technically, this is the right value, right? It's just not all the way solved down. So just remember, if you have a solid radical, then you need to go ahead and work it out. All right, number 3, we're dividing. Now here's the thing. We have a 2 and an understood 1. 2 divided by 1 is 2. Let me clean this up. Then we're going to match up our radicals. 30 divided by 5. 30 divided by 5 is 6. So this just becomes 2 square root of 6. Match up your whole numbers. Don't forget your understood ones. And then match up your radicals. 2 square root of 6. Number 4 is slightly different. 9 over 12 doesn't become a whole number. As a fraction, it reduces to 3/4. I don't know why that changed that pen to red, but 9 over 12 doesn't simplify to a whole number. It's going to stay as 3/4. Now if we look at 200 over 2, we're dividing, so we divide. 200 over 2 is 100. So what we have is 3/4 times the square root of 100. And again, the square root of 100 can actually simplify. The square root of 100 is 10. So technically I have 3/4 times 10, which is 30 over 4, which reduces down to 15 over 2. Now that was a lot of steps there, okay? So let me kind of remind you what's happening there. Match up your whole numbers, match up your radicals. If your radical simplifies, do so. And in this case, I had a fraction, so then I also had to add in my fraction rules, and then I had to reduce it all the way down. I don't know that you'll have very many with fractions like that in your homework. I will look through that and make a note if you do.